All right, I think we'll get started. So hello, everyone. My name is Mishra. I lead the developer relations group at HashiCorp, and I would like to welcome you to the second Nomad Community Call. It did take us a while to schedule the second one. I think we had our first one last year. And this is a really good time to schedule our second call because our Nomad 0.9 release candidate 2 has gone out today, which is super exciting. It has a lot of cool features. Hopefully today we'll showcase some of those features, and we also have a few community-driven demos as well. So for those of you who are new to the community call, I would want to give a bit of a background about the call. So the idea of hosting a community call was brought up multiple times internally at HashiCorp in the Nomad team meetings, and we had similar conversations in the field. Our DA group did. It was very clear that folks were interested in a community call around this project, and this is the only project at HashiCorp that has a community call, and hopefully we can grow this call to other projects that HashiCorp has as well. The primary goal of this call is to give folks a kind of a platform to kind of showcase things that they've built around Nomad or how they're using Nomad. It's very much a community-driven initiative. It aims to be, at least. The community agenda, the agenda might include demos and discussions and questions and anything else that the Nomad community wants to discuss in this call can be brought up. It's a kind of an open agenda. Another interesting thing to note is that the Nomad team will be participating in these calls directly to answer questions and even showcase features that are part of the latest release of Nomad. We also have folks that use Nomad in production. A part of this call as well. They'll be kind of showcasing some of the ways they use Nomad. So that's, I think, pretty much it in terms of the background of the call. Hopefully that gives you some context about the call. So let's get started. I think it's 9:04. Yeah, let's get started. So today's agenda, I'll quickly switch over to the slides here. The agenda is pretty straightforward. We have a few demos from our Nomad core team. These demos pertain to the new release candidate that just went out today. These include the new features that are added in the Nomad web UI. Michael is going to be demoing that, and then we have GPU features that were released as part of this release as well. Chris will be highlighting those things, and then on the community showcase side, we have Q2E Banking showcasing how they use Nomad. And we have a few folks from Q2E Banking team joining us on this call. You'll later hear from them. And then at the end is like the most interesting part of the call, which is the open-ended Q&A and for everyone. So there will be kind of a document that will be sent out as part of the chat that you can kind of use to add your questions there and use that document to kind of discuss things rather than Zoom chat. It gets quite noisy. I have a few announcements. The first announcement is the actual document that I was just talking about. The link is hashi.co/nomad-community-call. Pretty easy to remember. I'll post this in the Zoom chat as well, so you can open this document. So this document is basically, is the document for the community. You can add things to it. You can add discussion points. If you have demos for the call that hopefully will be scheduled in a few months again, please add them. Add those demos and kind of presentations as part of this document. And also the discussion section is open as well, so you can put stuff in there. We'll be covering most of the questions in that discussion section, and if we don't get to them, we would usually come back. The Nomad team would actually answer all questions asynchronously, and you can kind of view them at your own time. This meeting is being recorded, and the video recording will be made available at the HashiCorp YouTube channel and the HashiCorp resource page, usually after 3-4 days of post-processing. Also, please do mute your microphones as our presenters go through this presentation. All right, so those were like kind of the housekeeping announcement. I'll stop sharing my screen. So our first presentation is from the Nomad team. It comes from the Nomad team. We have Michael Lang, who is a Nomad engineer focused on the UI, web UI. I hope you have seen it or used it. So Michael will be showcasing some of the new features of the Nomad UI. So please kick us off, Michael.
Right. Thanks, Misha. Gonna share my screen here. Everything's gonna be a demo. So as demos go, hopefully it all works, right? The first thing I want to start off with is just sort of showing off the UI. If you haven't seen it, it looks like this. This is a cluster running on my computer. It's got nothing going on yet. Let's first start by looking at clients here. So as I mentioned, this is just running in dev mode on my computer. So the only client is my computer. In the UI now, we're going to be exposing metric utilization or resource utilization. So this is the actual usage of my computer. I have Chrome open, so I'm running out of memory, and I have Zoom open, so I'm running out of CPU. It's just sort of how computers seem to work these days. But we can also show stats for allocations and tasks. So the example I'm going to walk through is authoring a job that very deliberately makes use of these graphs by making a sine curve of memory usage. So super silly, but also kind of fun. Start off over here at jobs. We're going to run a new one. So now we can run jobs directly from the UI if you wish. So I need to fill this up with something. Over here in my code editor, I have a Rust program. It could be anything, but Rust is nice because the output's binaries and Nomad can schedule binaries directly. And it's also nice because there's no garbage collector, so I can have really fine control over memory allocation. So in this program, I'm basically just computing a sine curve right here, and then either adding or removing things from a linked list. Pretty straightforward. I have a corresponding Nomad file over here, which is my definition. So there's an update stanza. I'm running a canary. I have a pretty trivial healthy check, but that's just because this is a demo. See, I want 5 of these things. I'm using raw exec here because, again, I'm running off of my Mac, but you could use exec on Linux and get isolation if you want. But yeah, on my Mac. So let's just take this entire job file, plop it right in here. And then you'll see I have this plan button. So when I'm submitting a job through the UI, we're going to force you to use some best practices, which means starting off with plan. Plan was successful. This is what I'm going to get. And the dry run is fine. So I'm going to go ahead and run that. All right. And that's pretty much there. So now I have a job running. We should get all 5 healthy. Let's look at one of these allocations now. Cool. Metrics are coming in. You can see CPU is kind of unbounded and sort of doing its own thing. The chart tries to do its best to keep up. So even though we all hope that our CPU stays within our contained within our resources constraint, it's not always going to happen. So the chart makes sure to account for that. And then over here in the memory, we can see some sort of curves going on here as it sort of ebbs and flows using that sinusoidal curve. Not really happy with this. Personally, I think this is a little too sawtoothy. So I'd prefer for this to be kind of bigger waves. So I'm going to make a code change. I come here. I'm going to change this period value to 50 so I get bigger waves. Save that. And then directly from VS Code, I can just rebuild it. Cool. All right. So it's all built. Now I could update this, and I'm a fan of immutable infrastructure and whatnot. And normally I would make sure this is a wave 0.2, but I'm just testing stuff, and this is just on my machine. So I'm going to go ahead and be a little lazy this time. I'm just going to go back to the jobs page. I'm going to find the wave file or wave job, go into its definition, and then just edit it live. So I happen to know that Rust built this at this location with the name of wave, because that's the name of my program. So then I can just plan this with that change. You can see it's going to change what command is being run from wave 01 to this new wave. I'll hit run. And even though I did this as lazily as possible, this is still a Nomad job using Nomad conventions. And there was an update stanza with canaries. So one was placed. It's now healthy. I can promote this directly from the UI now. And everything's good. Cool. All right. So let's see how this works. Now that we see we have some jobs with version 1, if I can come here, we should be seeing bigger waves. All right. That looks like a slightly bigger wave for me. So essentially what this means is that we can now kind of have like a more relaxed workflow for dealing with submitting jobs. You can do it all from the UI. You don't have to set up your Nomad address in var. You don't have to worry about weird SSH tunnels or what have you, or awkward proxies in your way. As long as you have access to the UI and your ACL token allows you to submit, you can submit now. There is another feature though. So we're trying to make things mobile acceptable. So if we're on this page and we do this simulated iPhone view, you see this page now looks a lot better than it used to in 08 and especially in 07. So we're never really prioritizing making things work for phones just because it's not exactly a common use case. But the reality is sometimes you're on the go and something breaks and you need to put out a fire. So here we have a mobile view. It works okay. Let's go back to our client also. Cool. All right. So the other interesting thing that stats do, if you're familiar with the Nomad API, you'll know that there isn't actually some sort of storage backend for metrics. Metrics are always going to be read in real time. But the UI does what it can to preserve metrics for usage. So since the Ember UI is a single page application, we can do tricks like this, where we can preserve the metrics from earlier, and then essentially just have a gap in the chart from when we weren't actually pulling those stats. So we obviously can't pull everything under the sun. If you have a cluster of 1,000 jobs, there's no way we can pull all 1,000 of them. But the UI can do what it can to make sure that you have as updated view as possible for everything you've been paying attention to. And also, if you're not on the phone, if you like smaller windows, it's nice to have this little collapse bar. All right, so that's been the tour of the new UI features in Nomad 09.
Thank you, Michael. If you have any questions or feedback for Michael, please use the working document that's pasted, and there's some reactions coming in on chat that I pasted in the chat, in the Zoom chat. You can also use the hashi.co nomad-community-call link to get to that document. So next up, we have Chris Baker, who's also from the Nomad team. He works on the Nomad backend. Chris will be showcasing some of the new GPU features released as part of the latest release. Chris, take it away.
All right. Hi, everybody. So as Mishra mentioned, one of the things that I'm going to be talking about today is the new GPU features released as part of Nomad 0.9. Now, you know, at Nomad, we've actually always sort of worked to make sure that we could be as flexible as possible with the workloads that we run on Nomad. So in addition to supporting container runtimes like Docker and Rocket, we've always had the ability to run raw executables or raw Java applications as well, because we know that, you know, especially our enterprise customers, they have a lot of legacy applications that need to be run, and they don't necessarily want to be spending the time Dockerizing those. Also, you know, some people have, you know, constraints or concerns about running things like the Docker daemon as well. So one of the things that we've always focused on is the ability to run any type of workload on any type of infrastructure, whether it be Mac, Linux, Windows, ARM, that sort of stuff. So moving towards that goal, you know, we recognize and have recognized for quite a while that that any type of infrastructure for a lot of people includes devices like GPUs. GPUs are probably the best example of some of the devices that people want to have support for. But there's also devices like FPGAs, you know, hardware security modules, that sort of stuff. So what we introduced as part of Nomad 0.9 is the concept of device plugins. So this is our way of not only providing access to these types of devices, but actually the decision to use a plugin architecture means that not only are we not responsible for bundling these as part of Nomad necessarily, but we give users in the community and customers the ability to add custom devices for the devices that they need to support. So this is nice, especially if the stuff that you're doing is proprietary. You don't want to have to send the code to us to put into Nomad. You don't want to have to wait for us to do a release. So the way this works is for Nomad, we have device plugins. Let's see, wrong documentation, device plugins. And the way devices work is that the plugins will run on the node. And just as the existing Nomad agent will fingerprint the node, determine the available CPU, memory, disk space, and any other node attributes that it'll make available to the server for scheduling, the device plugin will also run on the node and does the similar sort of thing. It detects devices, it will detect their attributes, and it'll return this information to the scheduler for use by the scheduler for scheduling jobs. Then when it's time to schedule a job, the device plugin will work with the client to make whatever devices were scheduled available for that job. So I'm going to go and show you a little bit of stuff here from the job specification. So the way device works is it's just like any other resource in the scheduling stand. If you go into resources here, here's an example. You indicate that you want to have a device for your job, and you can then give it a name. This name field here takes a form. This one here indicates that you'd like a device where the vendor is NVIDIA and the type is GPU. There's a lot of flexibility here. You can say, I just want a GPU. I don't care about the vendor. You can be as specific as saying, I want an NVIDIA GPU of this model number. All of that's possible via this device stanza. You can indicate the count, the number of devices that you want. So if you want to run a job, you need 2 NVIDIA GPUs. You can just put in one device stanza and say, hey, I just need the count to be two GPUs. And then you also have the full capability of constraints, which you're probably familiar with from previous versions of Nomad, as well as affinities, which are a new concept introduced in Nomad 0.9, which allow you to express placement preferences. So these are ways of helping to pick out a node which satisfies your preferences without going so far as putting in a hard constraint. You can think of them as soft constraints. So what that allows you to do is you can take any of the information that was available from the device fingerprinting, like any special metadata about your device, any characteristics or properties of the device, available memory, certain hardware features, whatever it is the device fingerprinter for that device brings back. You can use that as part of constraints or affinities. So let's go on over to the live demo part of this. What I have here is I have a small Nomad cluster that I'm running up in Amazon, and I ran it with the Amazon GPU capable instance, right? I think it's a P3 extra large or something like that. So if I look here, I've got a single node. I'm going to look at the status for this node. And you'll see that in addition to the CPU resources, memory resources, and disk resources that we normally fingerprint when the agent runs, we're also the NVIDIA device plugin. I forgot to mention this earlier. The very first device that we had a support for is NVIDIA GPUs. So we have out-of-the-box support for that. And furthermore, because it's our very first one, we wanted to get it out there and make it easy for people to use. We're actually bundling that device plugin with Nomad. So that's not a separate plugin that has to be bundled. You actually, if you download Nomad 0.9, that device plugin is there, and you'll automatically have support for your NVIDIA device plugins if you choose to enable it, and if you have NVIDIA GPU hardware. So anyway, so on this node here, the NVIDIA device plugin detected, in fact, a NVIDIA device. It found an NVIDIA Tesla V100, and it fingerprinted it as having 16 gigabytes of memory. If I look at the status here in more details, actually, for this node, you'll see that it actually has, these are all of the device attributes that were discovered for that one. So you see it's got the device group. It knows about the bar buffer for doing a DMA. It knows about the clock speed for the cores. The driver version, this actually is a super nice one to have. If you have constraints on your GPU jobs, memory clock, amount of memory, power ceiling, all that sort of stuff. So the next step is actually to use a GPU device. So if I go over here and look at this job spec, this job is what it is a Docker container that I've got. It contains the NVIDIA CUDA runtime. It contains NVIDIA's build of the TensorFlow library, and it also contains Jupyter Networks, which is how I'll be driving the demo. And so if we go down here and look, we see we have a CPU request, CPU resource request, a memory resource request, a network resource request with a port for the Jupyter UI. And then here, the more interesting stuff, a NVIDIA GPU device. So here in the stanza for the device, I've indicated that I want a GPU with the model, with the vendor NVIDIA. and I indicated that I just wanted a single GPU. And I put in two little extra bits here. I want a constraint. I'm going to put in a constraint here that I need greater than 4 gigabytes of memory. So what I do here is I use the device attribute memory. Now I know from looking at the documentation that the NVIDIA GPU plugin provides an attribute called memory. So I know this is going to be available. And I've indicated here that, that I want the memory for this reservation, for this GPU, needs to have at least 4 gigabytes of memory. This is actually sort of interesting here because you know that this is a united value. If you go and look at the device documentation for the device stands on our webpage, you'll see that we actually have support for a number of different units. You know, if this was maximum wattage, right? I could go ahead and say, I need this GPU to be using no more than 150 watts. I don't know why I'd want to do that, but that's available, right? If I'm talking about temperature, if I'm talking about, you know, any of the things, any of the stats or attributes that the device plugin finds are available for this. The other one that I have here is an affinity. This is not a hard constraint. This just says, I'd like the device model, in this case, to have the word Tesla in it. It needs to match Tesla. So I'd like a Tesla GPU, but I don't require a Tesla GPU. If the scheduler can find me a node that satisfies all the other resource requirements and any hard constraints, it will score nodes which have Tesla GPUs higher, and therefore I'm more likely to get a Tesla GPU. This is super handy in many different use cases, but especially for these GPUs where I know that my application's gonna perform better, perform faster, maybe be more numerically accurate on a Tesla than on a previous generation. But I don't want to block the job if there isn't a Tesla. You know, if the only thing that's left on in the cluster right now at this moment is somebody's old MacBook Pro running an older GPU, then that's fine. Run the job there. So that's the job spec. So let's go ahead and look at a job. Nomad nodes or job status. I have a job running. It's this Jupyter notebook, as I mentioned. And it's already running. I ran it earlier because it takes quite a while. This Docker image is about 8 gigabytes, so it takes a little while to run it. So I already have it up and running. And if I go and look at the allocation for this job, you'll see that in fact it's running. It has a certain amount of CPU utilization, certain amount of CPU reservation, certain amount of memory reservation and utilization. And also you'll see here that in fact this GPU device is attached to this allocation. And we see here, in fact, that it's using almost all of the 16 gigabytes that were allocated towards it. So I'll hop over here and go ahead and show you this one. Here's the Nomad UI, by the way. You can see this nice job here, recent allocations, and here's this allocation with our CPU and memory stats, which aren't doing a lot at the moment. So let's hop on in. This is Jupyter Notebooks. In case you're not familiar, this is an interactive environment for doing, you know, data analysis, mathematical computation, that sort of thing. It's similar to MATLAB. But it supports a number of different, you know, different backends, MATLAB, Python, whatever. So here I've got a Jupyter notebook. It's in Python. And what it does is it's just a quick little object detection demo that uses TensorFlow. And so I'll go down to the bottom of the last step and run this. And what this is going to do is it's actually going to load up a couple of images that happen to be sitting inside of the container. And it's going to run them through a pre-computed TensorFlow model. And when it does, it's going to perform object detection on them per that model. And then it's going to display those images, and it's going to go ahead and label the objects that were found. And all this is going to happen using TensorFlow via Jupyter Networks. And then TensorFlow is going to call out and do the actual computation on the GPU. And you see here, while I was delaying, it actually finished the job. And here's the images that the model has marked up with information. So this is a dog with 94% probability, and here's another dog. And down here, you can't read this very well. I can't read it very well either. But these are kites, and these are persons. So this is just a cute little demo. This nice demos have pictures and video. So that is it for my part of the demo for GPUs and devices.
Thank you, Chris. So if you have any questions for Chris or some feedback, please use the working document. This is like the regular announcement. Next up, we have our community showcase. So we have the Q2E banking team presenting some of the use cases of Nomad. Cody from the Q2E banking team, hopefully he's on the call. Cody?
Hello. Let me share my screen here.
Awesome.
One second. Okay. So yeah, I'm Cody Jarrett. I'm a SRE lead at Q2, and Q2 is a internet banking provider for banks and credit unions throughout the U.S. And I just kind of wanted to mention that we've got about 12.8 million end users, and we closed the year 2018 with about almost $800 billion worth of money movement through our platform. Just kind of wanted to mention that when I start talking about our application and what we're doing with Nomad. And so I just wanted to mention some of our history and how we kind of got here. So a few years back, we kind of started looking into moving towards a more modern kind of application delivery and management style, management practice. And we had a couple of requirements when we started. We wanted something that wasn't overly complex management-wise. We really wanted something that had enterprise level support to kind of make it a good sell internally. And the product had to support Linux and Windows, and when it had to support kind of a traditional on-premise data center environment, but also potentially allow for growth into the cloud, some of the same management styles. And so that's how we landed with Nomad. And kind of our application overview in our environment, we have multiple kind of on-premise traditional data centers. We have traditional three-tier network architectures and Linux and Windows workloads. Our core business logic is written at .NET. And so our high-level goal was to move from kind of manually ran front-end Linux containers, almost equivalent of a Docker run, to and then individually installed back-end apps to kind of have the whole full stack of our application ran and scheduled by some sort of a centralized process. And then another thing that we had to look into was our application has a lot of customizations and a lot of pretty complex config files. And so our current Nomad status and our overview, all of our new applications that are being developed in-house are kind of deployed container first, being written inside of containers. And then our core application, our core online application, has recently been ported to containers. And we're currently in the process of migrating our new customers and any of our upgrade environments to run inside of Nomad. And today we have about 450 production jobs that's deployed between two data centers, two physical data centers. We have about 1,000 jobs in our staging environments, and that kind of equates to about 4,500 production containers, and then 8,000 if you include if you combine staging and production. In our production nodes, our Nomad clients, we're at about 240 nodes, and then about 400 if we include staging as well, and that's growing. And so just kind of a visual of our architecture. We have two sources of traffic for our Nomad clusters. We have end-user traffic from the internet, comes in through hardware appliances, and that hits our Nomad clients. We have our Nomad clients kind of dedicated, running in dedicated VLANs and subnets, and they're kind of separated by node classes. And then we also have all of our legacy applications running on VMs that are making calls into some of the newer products that we're developing, making calls directly into our applications that run inside of Nomad. Some of the ways we use Nomad is we integrate, or we use the integrations with Consul involved, and so with Consul we use it for a lot of service discovery. Of course, health checking to check the health of containers and potentially restart containers as they're become unhealthy. And one of the things that was really important when we were starting out was without having to make a lot of changes to our legacy applications, we were able to make use of Consul DNS for reaching these new applications that are running inside of Nomad and using Consul DNS. And we use Vault pretty heavily. We use it to store secrets like DB connection strings and general secrets, certificates and whatnot. We have our Nomad jobs have specific policies that are added to those that give them permissions to specific paths inside of Vault. When a container launches under Nomad, it gets a token automatically that has access to the secrets in Vault. And the template stanzas inside of the job files render these secrets as in either environment variables or directly into config files, kind of as needed. For our load balancing, we currently use Fabio. We run this as a system job, and so it basically runs Fabio on all of the nodes, all the Nomad clients. We have, inside of our Nomad jobs, we have, inside of the service stanzas, we have a tag, the URL prefix tag, to, and the way we use that is whenever we deploy a job and the service becomes healthy, Fabio is looking for that URL prefix tag in any of the services, and then automatically adds that route to its routing table, so that when we deploy a job, we can immediately begin hitting that application. And we're also currently looking into Envoy for some extra features we're considering, like zone-aware load balancing or traffic shifting. So some of the features that we use that we heavily rely on are the template stanzas and jobs. So our current approach is we create really generalized kind of generic containers, and then we lay in the really complex application configs at runtime. And we use templating inside of job files. And so we kind of treat our job files as kind of an immutable build artifact, and we store that in version control. We don't really have any kind of application configs that are living inside of, say, Consul KV or anything like that, where changes. We kind of like the idea of having everything live within that job file, just to kind of be able to version control it and whatnot. And here's an example of some configs. Over here on the right, we have a Telegraph config for a monitoring app that renders the config at runtime. And on the bottom, we have an example of a common, I guess this is a call to Vault to pull out a secret, an API key or something, and it renders it as an environment variable, and that's available inside the container at runtime. We also use Vault PKI integration. So since Nomad and Vault are so integrated, pulling SSL certs kind of dynamically on demand works really good. When our tasks start up and they get access to specific Vault policies, like an SSL certificate policy, a certificate's rendered into the Alloc directory, and then our applications are configured to check to see if the certificate's available and potentially use that certificate. That way we can do things like end-to-end encryption from the internet all the way down inside the container. And the container and the certificates and these Allocs and containers are really short-lived. We rotate these out. They couldn't live more than a month. And they auto-renew too. Another thing that we use a lot are the canary deployments. This kind of allows us to test changes and kind of introduce changes slowly or gradually. We can mark a deployment as failed if we see issues and kind of roll back. And we're starting to look into using canary tags to have a way to hit, based on URI, a new path potentially through Fabio, so we can steer our traffic directly to this new container that starts up, the new canary container. Something that was really beneficial to us was the health checking and then the automatic service restarts. So previously, when our application was running on servers, when that became unhealthy, it was we just have, we'd have to manually restart it. So now we leverage the restart and the check restart stanzas within the jobs, within the services. And that's been, really, really helpful as far as restarting pieces of our app whenever things are having issues. But it's also important to kind of keep an eye on that and make sure that you don't have a larger issue going on to monitor for things like that. Another thing that we use a lot are Nomad namespaces and ACLs. So we use ACLs to restrict access to specific sensitive namespaces to prevent installation, to prevent installing jobs or modifying jobs directly in production. And we also we have some namespaces for specific teams that based on their AD group, and they're allowed to deploy jobs. And that works using the Vault integration with our LDAP backend, Active Directory. And we have a namespace for our kind of our core foundational services like load balancing and Fabio. Okay, for monitoring, we have two solutions that we're making use of. So we use Logic Monitor for monitoring, making API calls to Nomad Consul Vault. We use that to watch some critical jobs and look at allocation health. And then we also use Prometheus. So we're running Telegraph as a system job that's not constrained, or it's constrained based on whether it's a Linux or Windows host. For Linux host, we run the Telegraph container, and then for Windows, we're using the exec driver to just install and run just to run the executable directly on the node. And that's been really nice because we can use the Consul service discovery option with Prometheus, so that Prometheus makes a call to Consul. It learns about all the nodes and automatically begins collecting metrics from them, things like Docker stats or Nomad or Consul stats. And then we have Grafana sitting on top of Prometheus for dashboarding, and then we built inside of Grafana we use some queries to do some comparisons and some math on the allocated versus the unallocated resources. And we can then look at the different node classes and do some capacity planning there. So that lets us identify node classes that are running hot, or that we need to add capacity to. And that's all I have. Thank you.
Thank you, Cody. I really appreciate your time. If you have any questions for Cody, you can use the document as well, or ask in the chat. I'm sure in the Q&A section we'll cover most of it. Okay, so I think we have a kind of a last-minute edition here. Other folks from Pandora on this call?
Yes, hello.
Sweet. Hey, Daniel.
Hey.
I guess Daniel will be presenting about their use cases with Nomad and Pandora.
Sure. Can I share now? Oh, there's another share happening.
Cody, could you stop?
So yeah, I saw our name on the email yesterday and I was like, oh, I guess I better do something. Let me see if this works. All right, I think I'm sharing now. So very briefly, we've been using the HashiStack here for quite a while, over 3 years for pretty much everything. And I thought rather than kind of go through very specific Nomad features, so just do a quick overview of kind of all that we're doing, where Nomad is really kind of a core scheduling component, but it's really a lot about the HashiStack here. So internally, we have Savage Cloud, which again that the HashiStack plus a pretty opinionated Jenkins build and deploy pipeline, heavily leveraging Levant for templating, and then Ceph and Postgres primarily for storage, not attempting to run stateful workloads under a scheduler. Pretty traditional enterprise environment, and so I get the Consul and Vault were brought in first to deal with kind of needs for service discovery and secret management across our more traditional VM workload. and so the scheduling was introduced after the fact. One of the biggest issues that we ran into going into kind of production with all of this was a need for separating namespaces, and so that's why we introduced a project registration system, and kind of the primary interface to that is just a simple form to register a new project. It sounds kind of silly and simple, but this is the only kind of touch point throughout all of our throughout all of the infrastructure around Savage Cloud that requires any kind of interaction from operations folks. So this is the kind of entry point for all of the Vault namespaces, Nomad namespaces, the Vault policies, Nomad namespaces, the LDAP groups that back that, just the kind of opens the doors for people to self-manage pretty much everything else. And then their kind of next stop after that is an internal tool called Bob the Builder. And really it's got its own service directory that backs that same project registration system, and just a set of templates for people to get started, and just a quick kind of demonstration of quick showing some of the Nomad config for this. It's a fairly standard Nomad job spec. Done some internal documentation for people to kind of go through and make modifications. Probably the most notable things that we're doing, we're building in the self-issuing or kind of evergreen cert management, and then we're heavily leveraging Levant. Heavily leveraging Levant for actually deploying these separate staging production, to different environments. And then primarily the main, point of access for developers is through this UI called Doppler. Doppler, it's, these are our actual jobs that are running, but just to skip past too much internal information on what everyone's up to, we'll demonstrate it on Doppler itself. So everything here up on the top is pulling from the Nomad APIs. We have, a deploy for this job in multiple different regions. And then, you can search, sort by tasks in the individual jobs. These are all, we're using HashiUI internally, as opposed to the Nomad UI. Maybe that'll change, but just a quick set of links for folks that people found very useful. The most notable thing for us here is running the actual, scheduling actual build and deploy jobs from this interface. Everything is locked behind Vault access. All deploys to Nomad require valid Vault tokens. And that was something that was a little painful to enable at the outset, but really, really important for us. And that's probably the biggest, secret sauce, I guess, for Doppler, is that when you actually auth and log in, it's using the, I'm not a web developer, so I'm not familiar with the name of the store that it uses internally, but I've been assured it's very secure, to auth to Vault in the background. And when these Jenkins jobs are submitted, when you're running a deploy and submitting this, it's transparently issuing an app role and credentialing the Jenkins job with the ability to deploy this job as it's been delineated by project registration. Hopefully that makes some sense. So that's really the kind of the main loop, I guess, for folks is creating a project registration, either starting with a template or often people will just work from an existing repo that they've done before, and then the actual getting the deployments kind of initialized through this interface. And so, yeah, our existing access right now, there's different teams using direct service discovery. We've tended to be a bit limited on our use of Consul DNS, mainly in that we're trying to keep it as an actual source of truth. And so the lack of a default TTL on that makes it not super performant to try and run everything through. Similarly, we've had issues with Fabio, where folks have tended to put Fabio URLs in places they shouldn't be. So I guess going through my list here, but yeah, the things have been the biggest wins for us. Consul DNS integration right away, and the ability to kind of focus on what is needed from a scheduler rather than chasing down kind of fads and fashions feature-wise has led to just a very, very stable environment here. We've only had one outage, and that was completely my fault. Otherwise, everything has been rock solid for years and years. And having this interface has made it so the developer experience between our on-prem, Savage Cloud and the deployments of that in GCP is identical. It's just they would also have access to API-backed features in Google Cloud. Some issues that we had, not requiring tokens from day one, huge mistake. It was very challenging to integrate some of that with our build and deploy pipeline. A lot of folks that we've seen have used kind of more the Nomad model to designate Jenkins as a privileged orchestrator and had Jenkins issuing either credentials directly or app roles for jobs. That was something that it took some work to get right. There's still definitely issues with resource allocations in Nomad and how to train and educate people on divining those, especially when traditionally you've been running in an over provisioned hardware environment. Cross and multi-region deployments are difficult, and that's something that's certainly been a leg up for some folks working with GKE and things. The ability to push one deploy and have that happen in multiple regions, and I know that's coming to Nomad. We also have had to generate some of the metrics here in Doppler. Actually, it's not visible from that interface, but there's some metrics that we feel like should be in Nomad that haven't been, like the allocated resources as well as the resources that are actually in use. So not having those has been, we had to generate them ourselves. And then something that I mentioned briefly earlier, but Fabio URLs where they shouldn't be. Making it too easy with the tooling to generate functional Fabio URLs has led to them showing up inside of inside of fairly tight loops in code, being used generally where they shouldn't be, and multiple round trips back out to a load balancer and back for situations where you could just be contacting the service that you need to talk to directly. So that would be, and then naming, of course, being that our Consul infrastructure is kind of global. The namespaces that all of these operate in DNS and service discovery are pretty universal. So that's really something that was very important for us to be a little more controlling about, and use the stick a little more for having people actually name projects after projects rather than teams. Or naming them after themselves, or all the various permutations. But getting usable, reasonable names for things is difficult but important. And that's kind of, I think, rounded up the advice inside of there mostly. Forcing people how to consider how their work was going to be divided was a huge part of transitioning things to this. It's not just smash a monolith into every single possible fragment you can have. Some teams definitely did that and ended up with their own kind of microservice hell. So, kind of also right-sizing the pieces you're going to break off of your monolith. Namespacing, having a very opinionated build and deploy pipeline. The Nomad job specs were definitely a great basis for that, but having a tight, relatively structured system around a default set of build and deploy, staging, and production jobs, and assuming Levant would be used in there, has been very useful for having builds that are diagnosable by other people, familiar to folks that cross teams. And, without that, there would absolutely be a proliferation of, kind of strange and one-off build techniques. And then, we've had a number of folks come in with pretty large and broad Kubernetes backgrounds, and the ability for them to understand kind of the architecture and the needs for different types of deployment and rollout procedures. Those have been the kind of the skills that have been most useful and most portable, as opposed to specific, certifications or knowledge of Kubernetes operators, APIs, or knowledge of Nomad job specs. So those kind of skills have been really important to build and really valuable. And I think that's what'll stick with your resume. Anyway, that was, hopefully people are still on the call.
Thanks, Daniel. All right. If folks have questions for Daniel, please add it to the working document, and we can kind of answer those. I think now we go into the Q&A session. We only have kind of 5 minutes, and we started 2 minutes late, so I guess 7 minutes. But we can answer some questions. Michael from the Nomad team will take over now, I think.
Hi, thanks, Mishra. I'll just go ahead and share my screen so everybody can see what I'm reading. Like Mishra said, I'm Michael from or another Michael from the Nomad team. Schmichael on GitHub and everywhere else. Feel free to also email me directly, always schmichael@hashicorp.com. Same as my GitHub username, because I know that there's a lot to discuss here and we don't have much time, and I would love to continue some of these discussions. So let's start up at the top. Somebody has a great question about integrating more directly with load balancers, cloud-specific load balancers, AWS-specific in this question, but I think the question is a good one and applies very broadly. We're actually building out an ecosystem team for Nomad at HashiCorp, as are a number of the other HashiCorp products, building out ecosystem teams, and some even already have them. And they'll focus on these sorts of integrations and hopefully be not just implementing a lot of solutions, but really helping us identify kind of the most important implementations and integrations for us to meet. I think, a FIPS certified load balancer is a great example of one where it's not something a lot of us on the team would naturally think of ourselves. So having community members and then this ecosystem team really help identify that need is going to be a huge asset. Moving along, can there be some way by which metrics-based scaling can be made part of Nomad itself? And this is actually kind of reiterated, I believe, in the next question as well. Auto-scaling being the way that I think, let's see, this is cloud specific. Yeah, auto-scaling I think is a fair way to kind of summarize this major feature. And it's on our roadmap. As always, we don't make any promises about timelines because we don't want to mislead anyone. But auto-scaling is definitely something we're looking into, is something that ecosystem team is going to be helping out with. And so expect news on that in the future. This next discussion is really great. And I really appreciate whoever Anonymous Anteater is and their willingness to kind of share these details about their decision-making process. Obviously, we're always sad when we lose somebody, but it's great when you share this sort of knowledge built up. One thing kind of as a meta point that I think we are going to need to discuss on the Nomad team and HashiCorp in general is how better to receive community feedback like this, especially because I know people don't make these decisions lightly. A lot of hours, a lot of research, a lot of development time probably goes into deciding between Nomad, Kubernetes, Mesos, which cloud you choose, which service discovery, service mesh. So much is happening, and we would love to know more about the decisions that people make and why. It's a shame that there's a lot of that information kind of trapped within everyone's organization. So until we come up with a better solution, always feel free to share those sorts of things on the mailing list. I know that's a little bit sensitive, so that's why I said my email address to begin with. Feel free to just send me these sorts of decisions, even if Nomad was what you didn't go with directly, just because there's so much good feedback in here. That being said, let's see how much of this we can cover before we run out of time. Okay, so tight integrations with the Hashi suite. And especially reliability being an issue. This is something that we take very seriously at HashiCorp, both the integration perspective and reliability. Vault and Consul reaching that 1.0 and beyond version marker should hopefully kind of signal to everyone that they've reached a certain level of maturity, as well as shifting a little bit more of their focus maybe away from that rapid feature development and more toward just rock solid reliability. Because we know just massive amounts of infrastructure rely on those services working properly every time. Nomad's moving in that direction as well, and obviously reliability is always a big focus for us. But more specifically, to the points mentioned here, isolating features or isolating failures is something that we definitely need to improve. I can't think of any particular tickets in the 09 timeframe that are going to improve feature or failure isolation, but I know that there's a lot of work scheduled for the Consul integration, a couple small things for the Vault integration. So definitely expect some improvements there. As a workaround, I do want to mention a lot of people have ended up using Consul template, the kind of utility that Nomad embeds to do a lot of Consul and Vault related operations. You can still use Consul template, the external utility, as a sidecar, as a system job, totally external from Nomad. And that may, depending on your use case, isolate failures. Obviously, workarounds like that are always more work than using a direct integration. So it's never something that we want to be happy with, but it might fit your use case today if Nomad's integration doesn't. Auto scaling we talked about, it should be coming. We love getting feedback about exactly what people are looking for there. Namespacing is a good one. Unfortunately, namespacing is part of our enterprise product, which I know is never what people want to hear, but we really aim to put features in the enterprise product that are built around larger enterprise organizations' needs. And so namespaces quotas are available there. But I think that at this point, the namespacing and more flexible scheduling goes a little bit beyond literal namespaces, the feature, and into the ease with which you can spin up Kubernetes clusters from cloud providers. No matter how simple we make Nomad, we can't compete with a cloud provider that offers a push button, Kubernetes deployment experience. So we're definitely investigating managed services here at HashiCorp, and you should be seeing news about that over the coming months and year. And then, yes, we absolutely hear you. We want to hear more of this sort of feedback. It's so useful to us to know what sort of data points are going into this decisions that people are making, regardless of what the ultimate decision is. Let's see, we're a little bit over, but I'm not seeing Mishra waving at me wildly, so let's see how much more we can quick cover. Task dependencies, they're coming. I see whoever posted that noticed that as well. Sorry it's taken so long. This is one of those epic 3-digit issues. We don't have many of those left, but we should be knocking off a bunch in the coming months. 010 and 011 in particular should be filling in a lot of those gaps that we've known about for a long time and just haven't gotten to until now. Things like our networking story, our storage story, plugins laid the groundwork for a lot of that stuff. So expect a lot of 3-digit tickets to die in the near future. The Helm charts for Nomad idea is Preetha has a great response to that. It's something we discuss now and then internally at HashiCorp a lot. Terraform kind of with its provider model, and now it has its kind of public registry of providers and things like that is kind of blazing that path at HashiCorp. We don't have any firm plans for that with Nomad, just because as it stands, I don't think we're happy with the level of templating we provide in our job files to make them generic enough to make sharing them extremely useful. It seems like people would still be having to heavily customize job files for their particular deployment. We do have a lot of templating improvements for job files planned, so it's definitely something that we should keep talking about in the future. Parameterized jobs. I love hearing people using parameterized jobs and batch jobs. I think it's a strong story for Nomad, and it's a story that we want to only keep making better. There's some small improvements coming in 090 actually that should make high volume workloads work a little more smoothly. And then in the dot releases, the patch releases after 090, so 9.1, 9.2. You should see some scheduling improvements that should lower resource utilization, decrease latency, improve correctness. Yeah, lots of little paper cuts coming in the 09X series. Preetha has a great response to the scheduling question on here, so I don't think I'm going to spend any time on that. Swap coming back. This is one I have to admit I don't think we get very often. It's definitely something we can talk about. I don't know if there's an existing issue for that. If whoever posted it wants to try to dig one up, that'd be great. And if not, please submit one, because it is something that I don't think we hear very often. So if you have the use case, please share it, and we'd be more than happy to accommodate it. 'Cause I don't think there's a lot of technical complexity there. I think it's something that we can support fairly easily, but wanted to provide the safest experience for users out of the box. API route to send a kill signal. We have good news for you. Pay attention in the 09X release series. 090 is, since it's in release candidate phase, is feature frozen. We're going to be getting it shipped here as soon as possible, but be expecting patch releases with a lot of little paper cuts and features and things like that released very soon. I'm not exactly sure what release we have the API to send signals to allocations slated for, but I know that work is already in progress, so expect it soon. Any tips for more advanced logging solutions? Any tips? No, but we do know that it's a pain point, and so that's something where we should probably build out tips and documentation in the near term. And the plugin infrastructure that we added in the 090 release will be used as the basis for logging plugins in the future as well. So definitely see a lot of attention in logging solutions, not in the 090 release, but probably in .10, .11, those releases. And then soft memory limits in Docker. I think so. I forget. I know there's been a lot of discussion on that issue on GitHub. And so I'm not sure I want to start adding things just off the top of my head. Oversubscription in general is a feature that we want to add and have good support for, as far as being able to oversubscribe nodes. I know that Nomad's strict memory limits in particular have been pretty painful for users, as well as the fact that we use megahertz-based CPU constraints as opposed to just being able to choose a core. those are both areas we're looking to improve in the future, and there's already a little bit of work started in that direction. I've gone quite a bit over, so I'll go ahead and hand it back to Mishra and let him decide how we want to go forward from here. Thanks, everybody.
Thanks, Michael. Thanks, everyone on the call. So we'll make the recording available in the next couple of days here. It'll be available on the working document. We'll tweet it out as well. So if you follow us on Twitter or follow our YouTube channel or subscribe to it, you'll have those notifications come in. As Michael said, we have the 09 release candidate 2 released today. Please go out and try it out. Even if it's on your laptop, just try it out. Find bugs, report them on GitHub, and that'll help the team for sure for the GA release. And then thanks for joining in. We had some really amazing kind of discussions going here. This is one of the things that we cherish. So please attend again once we announce the call, and please add some of the kind of the agenda items for the next call. If you feel that you have something to demo or showcase to the community, please feel free. This is all about you in terms of kind of the presentation and community discussion. So thanks for attending, everyone. Have a wonderful day.